I want to take a look at some of the algebra for the problems on lesson 2.3. So it's really not about the calculus, about finding the limit. We'll talk a little bit about that, but it's really around problems 5, 6, 7, and 8. And there's a lot of algebra in here that we assume you know. And so that's why I want to just highlight that. So the first one here is, this one here is a difference of two cubes. And so there's a formula that is on the formula sheet for the pre-calculus formula sheet that I provide for you. But here is a difference of two cubes, and you can see this is the equivalent expression for this difference of two cubes. The key on this problem is to recognize that 8 is 2 cubed. So there's your A and there's your B. So from there, in this example, you will see that I end up with this expression here, and then the numerator and denominator have common factors, and then we can eliminate those common factors there. So once you do that, then of course we're allowed to evaluate the limit, because right now when we substitute in, you end up with an indeterminate form. 0 over 0 is an issue, right, in mathematics. And so that's what then forces us to have to figure out, can we simplify this expression in some way that allows us to evaluate the limit, right? It's not the evaluation of the function, it's the evaluation of the limit. What is the behavior of this graph as x approaches 2? So I just want to make sure you're aware of that difference of 2 cubes and recognize why this top part becomes this here. And then I can substitute 2 into this new expression. You will see on the next one, question 6, this is a squared binomial, and that we need to then factor it out. So you just need to recall how to factor that out. We need to factor this, right? And then you simplify, and then you're in that same situation. Again, this is a rational expression, a polynomial divided by a polynomial. And so from that, that's what causes the issue when I substitute -7. So it's with this simplification that I'm allowed now to evaluate the limit by substituting -7, because this is, in its form, is a continuous function, right? It's just a line, and then allows us to then evaluate, right? The process of evaluating the limit is now I'm able to substitute into this simplified form. On number 7, this looks pretty imposing, right? Where you're like, I have no idea what to do. I know when I substitute 3 in, though, I get a indeterminate form again. And so you can see in this example, let me zoom in a little bit more. You can see in this example, I go from this step to this step, which is a common denominator, and then to this step here. And so another way to think about, right, rewriting the difference of two fractions is to recall this formula here. A over B minus C over D is equal to AD minus BC over BD, right? It's just a formula to subtract two fractions. And so once you have that, you could actually go from this point to this point, right? Looking at where you can see I have this difference, and then it goes over here to this here by cross multiply 3b, b, 3b on the bottom. Now, another thing you need to remember from the algebra is how we simplify fractions, right? A division of two fractions here. When we look carefully, let me erase a little bit, because when we look carefully here, we end up with this new expression right here, a fraction, a complex fraction, a fraction over an expression. Now, this expression, technically, I can then say that's over 1, and that's what was there, over 1. And so now I have a fraction over a fraction, a complex fraction, and that gets simplified to AD over BC. So writing this complex fraction as a single fraction, I'm allowed to do that, which occurs way over here, down here. Now, there's another algebra step that I've highlighted in yellow here. How do we go from 3 minus b to b minus 3, the negative, right? Well, the opposite, let me see where I have it, right here. So the opposite of x minus y, the opposite of that, right, is y minus x, right? And then if I do the opposite of that, what's the opposite of the opposite? It's the same thing. So technically, negative y minus x is the same thing as x minus y. And I can see this if I just distribute this negative y plus x, those are equivalent expressions there. They're the same thing. And so that is another popular move, famous move we use in calculus, and we end up with these expressions where they look identical, right? I have 3 minus b and b minus 3. It's like, I wish I could cancel them out, but you can if you rewrite this as its opposite. Okay, so once we have that, then we use this formula to go from here to here, which goes to here, because the b minus 3 would cancel. With all of that work, I am now able to evaluate the limit, because right now in its current form, I cannot evaluate the limit. Or when I plug in 3, I get indeterminate form again. So keep that in mind. All of that algebra in that one problem, this opposite move, okay? And then the last one I want to emphasize, let me erase a little bit here real quick. The last one I want to emphasize is this one here. Now, in order to think about this one here, looking at this here, you can see I rewrote this here, and it's a move. Where's the move? Is x minus 4x plus 4. And then x minus 16 can be rewritten this way, the square root of x times the square root of x. So technically, I can consider x a perfect square. So I do have a difference of 2 squares. The only thing here is that this is the square root of x squared minus 4 squared, right? And that's what leaves this. So again, it becomes kind of an advanced move to be able to do this conversion to write that in factored form. When you were in algebra class, many times the teacher would say, you can't do that. You can't factor that, but it actually can be factored. Anything can be factored technically, right? And so you have square root of x minus 4, square root of x plus 4, which gets rewritten. You can see when I do the simplification, you can see where it becomes x minus 16. And so that's what we have right here on the x minus 16. It becomes square root of x minus 4, square root of x plus 4. And then that allows us to cancel those out. And then I end up with 1 over the square root of x plus 4. I'm then able to evaluate, right, this limit by plugging in 16. And you can see I get 1 over 8 in this case. And so it's important to kind of see that we're rewriting this in a simplified form. It's not technically equivalent or equal, because when I substitute 16 in here, I get no indeterminate form. So it's not the same as this one, but it is the simplified version of that. That's some algebra I want you to seriously kind of review and think about and use in the future. Thank you.